about is today is about maybe just share a little bit about what I'm doing here in Hawaii, and also perhaps give you share a little bit about my journey, about how I get here, and how it could relate to your own personal journey and where you are. Perhaps you are a student, perhaps you are a young faculty, you're a resident, and all med students. Hopefully you can take something away from this short time that we have. So just like Dr. Sri Dawana said, just a little bit introduction about myself. I currently mentor about 20 medical students from JAPSON. These are what we call the Brain Research Innovation and Translation Lab program, or BRITO program. These are some of the best medical students, I think. I can't imagine why would somebody want to do extra work unless they're really motivated and they want to rise above the rest, want to be cream of the crop. So I think these are some of the best medical students. The picture at the top, the three leaders. The lady in the middle is Julia. She has actually done research with us ever since she was a master's student, and continued doing research with us throughout her med school. And then on her right-hand side is Ward. Weldon, they're both third-year medical students. Ward came from MIT, and it's just an amazing med students. So those are the together with Anson Lee on the left-hand side of Julia, who's also another wonderful med student that's going to cardiothoracic surgery. They lead the rest of the 20+ medical students. So mostly first, second year, and we do have a couple of third and fourth year medical students working with us as well. And in the BRITO program, we have wonderful faculty with us. Dr. Virek, that's standing beside me. He's the neurologist with the bow tie. He's famous for that. Dr. Larry Bridges, who's the dean of or director of student affairs, the dean of the students at the medical school. And then Dr. Jeanette, who is a psychiatrist, neurologist, who also mentor our students. So really grateful to all of the faculty who are able to work with us to do that. And then on the bottom picture, you see the interns, there's other undergraduate students. We actually even have 2 high school students that with us. Obviously, these are undergrad students that have come from all over the place, from UH and East Coast. Most of them are actually local students that are going to school, whether they are at Yale, Berkeley, UH, Northwestern, Notre Dame, UC Davis, you name it, we have it. We even had undergrad students from Harvard here and Yale, and and also every year we pick 2 high school students. This year our high school student is I don't know if you can see the arrow here, Chanson, who is from Kamehameha School. And Chanson is one of he's actually his second year doing this program with us. Chanson, he's actually got into pre-admit at Harvard, and after doing his first year, and he came back and this year to do a second year. So we're really proud of them. These are again some of the best interns that we have in our program. So besides mentoring the med students, oh, by the way, if you're interested in the BRITO program, go ahead and here's the link. You can QR code that, and some more information about the BRITO program. And you can apply if an undergrad. You can apply for next summer. The current batch are already selected for the med students. So we will be accepting application for next summer. Other things besides mentoring medical students, what I do is I spend most of my time doing clinical research in various neurological disorders. A list of my active clinical trials. They're in various stages, phase 1 through phase 4, quite a number of Alzheimer's, whether working on amyloid or tau, or NMDA receptor, or synaptic neurosynaptic plasticity or axonal transport, offering different ways to try to tackle the problem. Also do a couple of Parkinson's study, looking at LAC2 genes and calcium channel blocker. So the Alzheimer's trial, they are basically disease modifying trial. Obviously trying to not just a symptomatic trial. Parkinson's trial, the first one, LUMA, is a disease modifying trial, and again, the second, the axonal transport for Quantitative is disease modifying calcium channel blocker, is a symptomatic trial. Epilepsy trials, obviously in trying to inhibit the hyperexcitation in epilepsy. So I know it's just a lot of clinical details, and but this is just to kind of give you an idea. And this is my wonderful clinical team that works with me on the clinical trial. And so what is it that makes a good researcher? How did I get started? And what do you need to do? Taking care of a lot of seizure patients. So one of the problem with a seizure patient is they forget to take the medicine, because some medications you have to take them twice a day or 3 times a day. So as a result, they come in with seizures because they forgot. But who takes medicine 3 times a day, right? I mean, once a day, it's hard enough. So one of the things that I thought about, I thought about, what do I need to do? How do I improve? How do I get them to take the medicine? Because if they take them once a day, they don't achieve the steady state or the equivalent symptom seizures. So they have to take them 3 times a day. One of the potential solutions is putting them on, so they were taking trileptal, which you have to take twice a day or 3 times a day. The solution is to put them on Oxtella, which is actually just an extended release. Same medications, just have to take them once a day. So it has a more steady state, easier plasma life and steady state. So as a result, I just signed on to this clinical trial because I was just trying to find solution for my patients, because basically I'm tired of seeing them back in the clinic because they come back with seizures. So so I put them on Oxtella. I signed on this clinical trial, put them on Oxtella, and lo and behold, when I put them on once a day, the compliance went way up. Once a day, how can you not do it? Just put it beside your toothbrush and take them once a day, and they have less seizures. And as the compliance went up, and it worked. So research doesn't have to be something very complicated. Doesn't have to be, a lot of people, they say, oh, I want to do research. This is not interesting, or this is really interesting. Think about what you are already doing. Think about the patients that you're already seeing. Think about problem. It's just about problem solving. Start with something simple. Start with something basic and practical. How do I help my patients? What solutions can I offer them? How do I improve their life? So I just want to encourage you, don't look for a project with NIH or something, complicated, trying to cure cancer or what have you. Look for something simple, basic that you're already involved in. It's a lot easier. So my first thing is, to be successful during research, is what you're doing useful? Think about in my case, it was just once a day medication for my seizure patients. It was easy to take, increased the compliance, and it helped my patients. How does it benefit the people or the community that you're with? What are you already doing? What are you involved in? Who are you taking care of? What projects you're already doing? What can you do to improve the lives of other people? So just start with something small. So, by asking the question, is what you're doing useful? Okay. So I also want to share my experience being a fellow at NIH. So when I was at NIH, I work on the 5th floor, Building 10 at Clinical Center, which is a wonderful place to be if you've ever been to the National Institute of Health at NIH, Bethesda, Maryland. I was with the NINDS, or National Institute of Neurological Disorders and Stroke. At the time, as a fellow, one of the things that I was studying was called gelastic seizure. It's basically laughing seizure. So the patients is basically presenting with uncontrollable laughter. You're thinking, how can laughter be a bad thing? It is a bad thing if it's a seizure. So what happens is they actually have a little lesion in the middle of the brain, in the hypothalamic region, called hypothalamic hamartoma. Okay, so a hamartoma is a normal brain tissue or cortical neurons in an abnormal location. That's what it is. So when it is in an abnormal location, so a seizure mainly is just abnormal electrical discharges. So my patients, when it discharges, it activates certain parts of the brain that causes mirth, or the sensation of funny, so they just couldn't stop laughing. So it was a really interesting condition. And NIH was such an amazing place. It was a rare condition, but because I was at NIH, I took advantage of the fact that we actually this is the world's biggest research hospital, Building 10. I took advantage, this is in the 90s, and I took advantage of the fact that we have the resources of the US government at our disposal. We can actually look for these patients wherever they are in the world and pay for them, fly them to Building 10 at NIH, and then study them. Imagine the opportunity that I have. That's amazing. So we actually fly these patients from wherever they are, from Ohio, from California, from Argentina, from France. I contacted them as a fellow, and by phone and by email, would work with the physicians to fly them to NIH Building 10 at that time and study the seizure, do the EEG, do the MRI. One of the things that we actually discovered is this patient actually has a genetic predisposable. At that time, so we got the geneticists involved from the NHGRI, National Human Genome Research Institute, and there was some sort of genetic connection they called a hedgehog gene at that time. So I thought, wouldn't it be cool if I could get involved in the genetics, of studying this rare condition? So I went to Dr. Leslie Biesecker, who is studying the hedgehog gene at NIH at that time. I said, Dr. Biesecker, I really wanted to get involved in the genetics. Is so cool, so sexy, I wanted to get involved. So he said, okay, great. So he set me up with one of his lab postdoc. And my job was at that time to go and do the basic science, basically pipette, the tissues and, through the PCR and all that fancy basic science stuff at NIH. And guess what? I found that is the most painful thing I've ever done. Sitting at a bench, pipetting things and doing that, it drives me nuts. Guess how long did I last in the lab? Less than a week, and I just found out that is just not my calling. My calling is to really see patients. I love the patient interaction. I just could not stand burying myself on the bench in the lab, just pipetting, and I found myself dying, every day that I was in the lab. And at one point I just say, just do anything. I'm going to go and have lunch just to get away from the lab. So to be successful in doing research, you should ask yourself, what are you passionate about? Do you really want to do what you're doing? Or are you just doing that because it's an opening there? Or are you doing this because somebody else said it was cool to do that? Maybe you're in basic science, maybe you're in epidemiology, maybe you're in medicine, maybe you're in a specialty, maybe you're a resident doing medicine or orthopedic surgery, whatever you're doing. Maybe as a medical student, somebody said that plastic surgery makes a lot of money. You want to do it, but are you really passionate about this? How do you know what motivates you? Is this just an infatuation, or can you see yourself doing this for the rest of your life? The way that I often tell the medical students here, whatever the specialty that they really want to go into, some of them say, oh, I'm going to be an orthopedic surgeon, I'm going to be a neurosurgeon. I said, let me just ask you something. Would you still go to work if you didn't get paid for what you do? If they can say that, yes, I would go to work if they don't pay me, that's a good chance. That's really your calling. That's what you're passionate about. So if you only do that because they pay very well, or there's some huge motivation, that's huge incentive to do that, and then if we take away those incentives, you probably say, oh, forget it, I'm not going to do it. That's a good chance that that's really not what you're passionate about. You're just infatuated with it. Somebody told you was really neat. So whether you're doing basic science, working at the bench, or clinical research, working with patients, or somewhere in the middle, translational research, ask yourself that question. What are you really passionate about? Would you still go to work if nobody pays you for doing what you do? So I also wanted to share a little bit with you about what I'm doing right now. So I shared about what I did as a young attending, young faculty on the mainland, and shared with you what I was doing as a fellow. I want to share a little bit about what I'm doing right now. What I'm doing a lot is looking at Alzheimer's dementia and how to detect them early and accurate. So is it okay if I just dive a little bit into the science? I know this is, I hope that the students wouldn't tune me out and just put me on mute to some. Take you on a little science journey here. So so if we think about Alzheimer's, it is common. It affects 6 million Americans. So everybody, almost had somebody that's affected, whether it's your grandpa, grandma, friend, uncle, auntie, everybody knows somebody affected by Alzheimer's. So Alzheimer's dementia or disease is accumulation of abnormal proteins. It's a neurodegenerative disorder. It's a disease of aging. The challenge with Alzheimer's disease is the detection. So most of the time when we get our patients, when we see our patients, they're often too late. Grandpa is already, 5 years into the disease, and there's already too much tangles and plaque in the brain. There's not much we can do. The challenge, I think the golden grail to solving this problem is having early and accurate diagnosis possible. But who wants to go to the doctor if they're not having memory loss? We think that the process actually starts about 20 to 25 years before you actually develop memory loss. So if you develop memory loss at, let's say, 65 years old, that process already started at age 40. But think about it. What 40-year-old would want to go to a neurologist and get tested? Nobody. So is there a better way to get tested? So in most diseases, we have what we call biomarker, whether it's cancer, or prostate, you test PSA, for colon cancer, you can look for a biomarker, a blood test of some sort, and in the heart disease, cardiovascular disease, you can look for a blood test. But what's the problem with getting a blood test with Alzheimer's? So the problem with blood-based biomarkers for Alzheimer's is threefold. The first is the blood-brain barrier is very impermeable. So the abnormal biomarker that we see in the spinal fluid in the brain, what we call the beta amyloid, whether it's amyloid precursor protein or beta amyloid peptides or oligomers, they are, or tau or T for total tau and P for phosphorylated tau. or even NFL neurofilaments, which is an indicator of neuronal damage. The other up-and-coming reactional biomarkers that we're after is neurogranin, which is actually an amazing biomarker that we can actually sample in the CSF, which we are sampling in some of our Alzheimer's study currently. All cytokines are not that well. They don't get into the bloodstream because of the impermeable blood-brain barrier. So in the bloodstream, they have a low concentration and often non-detectable. The second challenge is if they can get out of the blood-brain barrier into the bloodstream, the plasma, the blood just destroy them. You know, catalytic enzyme just totally destroy all this biomarker to a non-detectable level. And the third thing is, even if it doesn't get destroyed, these biomarkers get degraded very quickly in the plasma, you know, by different, you know, so we don't have, I don't see blood-based biomarkers for Alzheimer's anytime become a mainstream soon in the next 5 to 10 years. So that's really the challenge. So what do we do? So what are the current biomarker that we have? So as you know, we don't define Alzheimer's disease by memory loss anymore. You know, in the old days, we defined them by pathologic findings. You find a plaque in the brain on autopsy. But what could use a good autopsy if the patient is already dead, you know, or if they have memory loss? We don't even care if you have memory loss now, because by the time you have memory loss, by the time you send them to the neuropsychologist, there's something wrong. It's really too late. You know, what we really want to define Alzheimer's is by biomarkers. So the three present biomarkers that we have is MRI. So MRI, we look for atrophy or shrinking of the brain, degradation, especially in medial temporal hippocampal area. So we look at four things: global cortical atrophy, number one. Number two is medial temporal atrophy. Number three is parietal atrophy. So the atrophy has to be in the parietal region. And number four is small vessel white matter disease, or what we call the Fazica score. So on the MRI, actually, we actually look for very specific findings that can define Alzheimer's disease, even before they have memory loss. What about better tests? Better test is actually a PET scan. You know, a PET scan is positron image. PET scan is looking at metabolism. So in amyloid PET, this is actually a FD amyloid PET. We're looking at increased amyloid, or we also look at decreased metabolism. This is an FD glucose PET scan. We see that there's decreased metabolism, especially in the parietal and the temporal lobe. Again, PET scan, we don't even have them in Hawaii because of the unstable nature. We actually can't fly them from LA because they get degraded too quickly, and we just don't have enough volume to make enough of them in Hawaii. So I have actually one of the study that we're doing, we're sending our patients to Los Angeles for the PET scan. Obviously, what we're doing most of the time, every week, we're doing spinal tap to sample the spinal fluid of our patients. But everybody knows spinal tap is invasive, putting a needle in your back. How many of you wants to volunteer for a spinal tap? Okay, nobody. So neither do I. So it is invasive. You can get a headache for about a day or two. So what do we do? What are the options? So what can we do to find things that are non-invasive, widely available, and cost-effective? So, so this is where I started looking at. So my specialty is cortical neurophysiology, looking at synaptic plasticity, functional plasticity. So, so MRI, PET scan are what we call static tests, looking at static parameters. What we really need to do, or structural, what we need to do is looking for functional deficit. You know, especially Alzheimer's is really a loss of neuronal synaptic connection or synaptic loss and dysfunction. You know, so what we're looking for is using EEG and ERP, EEG is electroencephalogram, and ERP evoked related potential, to measure neuronal and synaptic loss. so which is actually a really good way to measure neuronal loss. And it's a functional test too. So how do we do that? So think of Alzheimer's as a loss of synaptic connection in the brain. So as you get more progressive in the disease, there's more loss of synaptic connection. So synaptic connection is measured in the EEG by quantitative power, what we call gamma power. We look for very fast activity, EEG frequency. So as the connections get lost, we see there's less gamma power, and we also look for evoked-related potential. As the connection get lost, it takes longer for signals to go from one part of the brain to another part of the brain. That's what we measure. Usually it takes about 300 microseconds to measure that. But okay, so this is on the left-hand side, you can see that this is a measurement of P300, event-related potential. As the Alzheimer's on the rate scale gets worse, it gets longer. The scale gets 400. It can even get up to 500, but in healthy patients, it's usually about 300 microseconds. P is for positive, the waves going up. Okay, and then quantitative EEG is measuring gamma, which are very fast activity. As the Alzheimer's progress, there's less gamma activities. So as the Alzheimer's progress, we have less gamma, beta, and alpha activity, and more theta and delta activity. So the frequency of the brainwave starts changing, starts shifting towards a low frequency. Okay, so a lot of science, but hopefully I didn't lose you guys yet. So just to kind of give you an example of how this is actually put into practical application. This is one of the study that we're doing, that's NIH-funded study, a phase 2 study, looking at ATH-1017. We are Hawaii site 151 among about 40 sites in the country. So we're dosing our patients on fosgonimeton or ATH-1017. So let's look at first the graph on the left-hand side. So on the orange graph, you see the patients on placebo. Okay, so this is ADAS-Cog. It's a measurement of the memory skill. So patients on placebo, over time, you can see that there is a decline in memory. So you have patients on placebo and patients on drug. So patients on the drug or fosgonimeton, there is still a small decline, but there's definitely a statistical difference in the decline. And then on the right-hand side, we're measuring evoked-related potential. So these are actually practical things that we are already employing in clinical trials. So in the orange graph is patients that are on a placebo. Over time, there takes longer. The P300 frequency, there's increase, takes longer, 10, 20, 30 milliseconds for brain signals to be conducted from one region of the brain to another region, while patients on the investigational product, in the graph on the purple, there's not only stabilization, but it's actually improved. So this is really exciting. We have about 12 patients in Hawaii on this study, and this is really the graph that I show our patients that, look, you're on a study, hopefully you could be on placebo, you could be on drug, but this is why you're in a study, because it's working. So one of the things that we are doing on our own is we're looking at patients 65 and above who has no memory loss, who has but has asymptomatic, but has high risk for developing Alzheimer's. That means that they are ApoE4. ApoE is a genetic allele that we can test. Very simple. You can actually just take a cheek swab or saliva and send it for 123andMe. If you have E4, you are double allele, or you just have E4 carrier or E4 negative. E4 is you have one set, you're 4 times more likely to develop Alzheimer's. You have 2 sets, you're 12 times more likely to develop Alzheimer's. So we're looking for patients with E4 carrier, and then we're looking at EEG. So E4 carrier, we've seen that there is a more percentage abnormal slowing, especially in the temporal lobe, which makes sense, which is the memory function of the brain. And we published this and presented its findings at 2021 Alzheimer's Association International Conference, and also at last year American Epilepsy or EEG Society meeting. So this is some of the wonderful students and neurologists that are working with me. Every year we have one medical student that is studying from Celine, and then Anze, and then Carissa, Nathan, Kim, and then this year we have Shay, and then we are actually selecting a first-year medical student to be on this project as well. My hope is to really use AI, machine learning, to really extract the EEG data. My hope is if AI could figure out what I like to drink at Starbucks, whether I like a venti drink, grande drink, how many pumps of syrup I like, whether I like pumpkin spice latte or I like caramel, that AI figured all that out. How can they not figure out, how can we not use AI to help us to solve this problem? So they are already doing it, and the study is actually done in Italy. The push is to really develop a non-invasive, affordable, and widely available biomarker that's reliable, sensitive, and specific. That's functional dynamic biomarker for early preclinical detection. Number one, and also for disease progression monitoring. We can look at the frequency and see how much progress, and then correlate these findings with amount of time, modality, whether it's genomics, CSF, or imaging. And we already have those data, genomics, CSF, and imaging in our database here at the Memory Center. So why can't we do that? So I'm currently speaking with several computer scientists and AI experts to look at some models. So if any of the students or anybody who is an expert in AI, tell them that I want to talk to them. We want to use the best method. We want the smartest people to really solve this, one of the most challenging medical challenges that we have. So here's the challenge again. By the time that we get to dementia, it's really too late. So what we really want to do is find people who are cognitively normal before they even get to the MCI, mild cognitive impairment stage, and we start intervene at this stage, because by the time they get a abnormal neuropsychometric testing, it's really too late. The tau and the beta amyloid pathology is in ripe stage. First you have the beta amyloid pathology, and then you have the tau pathology. Even by the time that we get MRI abnormality, it's really too late. Is it possible that we could use EEG? Obviously, the current biomarkers is spinal tap and PET scan. It's invasive, not widely available, and cost expensive. Is it possible we can use EEG as a surrogate biomarker for this? So this is really the research that I'm working on right now. So how did I get into this? I spent 3 years at the NIH looking at cortical physiology, looking at EEG. It seems really why people often ask, you spent 3 years looking at EEG. Is there really that much things to look at in EEG? Yeah, I mean that's what research is about. So really have a natural that you're passionate about, that's useful, that ask yourself, is this your area of expertise? And the good news is, if this is not your area of expertise, who can you pull in to your team to help, to collaborate with? So the nice thing about research, because there are whatever that you think you're great at, whether it's a cardiology problem, it's a GI problem, there's people who are really good at that. What I really need to do is reach out to them and pull them into the project. And that's exactly what I have done. For example, looking at a tree, are you good in basic science? Are you good in clinical research? Or how about health population? you can't really be good in everything. Pick something that you're good at, that you're skilled at. And then if you're not skilled at, look for people to collaborate with. Look for people to work with you. See what Donald did and publish. Congratulations, Dr. Siri Dawana, for publishing this paper in the Journal of Alzheimer's Disease Reports. We're so fortunate and to get to be part of what he's doing, because epidemiology, quantitative is not really my area, but I was able to collaborate with Dr. Siri Wadana, and this is the results, and Dr. John Chen, and this is the results of what happens when the power of collaboration. So don't be afraid to reach out to other people. Don't be afraid to ask people to work with, and if somebody says that I don't want to collaborate with you, go and ask somebody else. I'm sure Dr. Sri Wadana, anybody would be glad to collaborate with Dr. Sri Wadana. And it's a good thing that I didn't say no, because when he asked me, I was like, yes, let's do it, So don't give up, find good collaborators. So what is it that you need to be successful doing research? It really boils down to UPS, and it's not United Parcel Service. U is for useful. Is what you're doing useful? P is for passion. Sorry for the typo. What are you passionate about what you're doing? S is for skillful. Are you skillful in this area? So you can really break it down to three things: useful, passion, and skill. I'd like to finish by sharing the story of an international medical graduate and Dr. John Rose with you. There was an international medical graduate that was doing his residency at the University of Utah, and because he was an international medical graduate, he asked everybody. Every one of the faculty, every one of the faculty in neurology, faculty, do you have research? Everybody said, no, I don't have any research, and and he really wanted to do research. He is actually in Utah. And finally, he looked at this international medical graduate and said, you really want to do research? Why? So this international medical graduate said, well, I am an international medical graduate. The only way for me to really leverage the playing field is to really stand out and do something extra. If I just, go about and say, okay, show up at the VA at 8 p.m., on a Friday, so this international medical graduate showed up at the cage of rats. The rat's poop, taking out the rat's poop and clean the cage, and it was stinky, it was dirty, it was dark, but that's what this international medical graduate had to do to get his research project started. And true and lo and behold, Dr. John Rose saw that this resident was very faithful, showed up. You have to show up, you have to be faithful, and you have to be persistent and resilient. So, and eventually they published a small paper, an abstract, an interleukin, something, and it really spiraled. Once one of the door got open, the resident asked again, another attending, do you have research? I have done some research, Dr. John Rose, and we have published this abstract, and then the attending says, really, you really did. So let's do this. And then so eventually the resident was able to get a number of abstracts published, and even one paper published as a resident. Because he had research under his belt, it really opened up tremendous opportunity. When he was applying for residency, there was probably about 5 programs that replied, but because of research, the resident was able to have at least 30 fellowshipping. Institution like Harvard, Yale, Duke was even responding to his request for fellowship. So basically, research really opened the door for this resident. So this resident eventually went to the National Institute of Health. So just in case you're wondering who the resident is, that's me. I was the resident, and this is the professor, Dr. John Rose, that gave me a chance when nobody else gave me a chance to do research. So I just want to give credit to Dr. John Rose for, over 30 years ago, saw the potential in somebody who came from Singapore and who's an international medical graduate, and gave me a chance. And because of that, I was able to open doors for me personally as an international medical graduate, and one doors open up one after another, and it really made a difference in my life and my future. People who succeed in research usually shows PRE, and it's not pre-med. P is for persistence. Okay, so when you ask somebody, to do research, when you knock on the door, that's a good chance that somebody's going to say no. Just like I knock on many, many doors. I probably asked about maybe about 15 to 20 neurologists before I ran into Dr. John Rose, and Dr. John Rose said, great, I'm going to give you a chance. Let's do research. So persistence. So if somebody says that I don't have a research project, be persistent. Ask again. Number one. Number two is R is for resiliency. You got to have a thick skin. When people say no, you just pick yourself up and ask again. Go to the next attending, because somebody out there is going to give you a chance. Somebody out there is going to see the potential in you and believe in you. And then E is for excellence. Obviously, do a great job when you have the opportunity. Show up and show your professor that you are worth the time and investment in. Obviously, if you don't show up and if you blow off the opportunity, that's on you. What I really like with some difficulty, when you see no opportunity, when you see everybody says no, that's when really lies the opportunity. So to be successful in research, be persistent, be resilient, and do them with excellence once the opportunity comes your way. I'm privileged because it needs the way of research, because I was one of those students that the doctors turn away. So I try not to turn. I have the privilege of mentoring a number of students. My encouragement to you is, why don't you be a Dr. John Rose to somebody? When somebody asks you for something, so into their lives, because you never know that one student, that one person that you're good to, that you're kind to, who they might turn out to be. Another favorite saying of mine is, a generous man will prosper. Be generous. He who refreshes others will himself be refreshed. When you're generous to people, somehow you will grow yourself. So look for opportunities to help others. Look for opportunities to support others, to sow into their lives, especially people who have nothing to give you back in return. So if anything that I can say that I encourage you to take home today is, be a Dr. John Rose to somebody else, because you might never know. You might that somebody else might be me. When you're generous, when you're willing to mentor, you get a team. People want to work with you. And here's another paper that came out this month. Here's Anson, Anson and Julia, two of our student leader, and Connor, the student leader the year before, and also several 3 undergraduate students, and also Dr. John Chan and our 3 neurologists working. And we published another paper in Cognitive Behavioral Neurology on the barriers to Alzheimer's disease clinical trial participation in minority population. And this really goes a long way. When you're generous, when you're willing to open yourself, invest in others, there is really power of teamwork. Time is. I want to tell you about a patient I saw yesterday. we're going to finish up with this story. I saw Brian yesterday, who flew in from the Big Island. He's a physical therapist. Excuse me, he flew in from Maui. He's a physical therapist from Maui. I hope that you don't know any physical therapists from Maui. Just call Brian, but if you do, hopefully change his name. So Brian is only in his early 50s. Unfortunately, I believe that he has early onset Alzheimer's disease. So he sought me out because he thought that I had something to offer, that we can give him the care that he needs. We can give him something that very, very helpful. He talked to, he's in the healthcare. He talked to many doctors before he decided to fly over here to Honolulu to the memory center to sort us out. We spent a lot of time talking about the pathology of Alzheimer's and what early onset Alzheimer's is and what his future looks like. But what really struck Brian was his parting words to me is, Dr. Liow, it's great that you know what you're doing, but it's even better when you actually care about me as a person, So to those students who aspire to be doctors or whatever that you're doing, I hope you remember that nobody really cares about how much you know until they know how much you care. Before you even tell them, show off your knowledge, let them know that, that you care. You care about them. That's really an important thing, especially if you're a physician. So this is, and every day I learn from my patients. They are my teachers. Constantly I learn from them. So I hope you take away with some good messages from today. So I guess I just want to finish up with really ikigai, and some of you may know this is the Japanese meaning for a purpose of doing or being. So 4 things in life: what you love to do, what you're passionate about at the top, what the world needs, what's useful, and what you're good at, what you're skillful at. Okay. And then I rarely worried about what you get paid for, because I always tell the med students, if you do what you love, what the world needs, and what you're great at, the money will follow. Don't worry about the money. It's a natural. So some people are in the wrong category. For example, you could do what you love, what the world needs, what you're passionate about, but you don't get paid. It's you're a nonprofit, or you're doing something. Or you can do what the world needs, what you love, what you get paid for, but you're horrible at doing it. I've known several doctors who are just not good in their specialty, but they go into it because it's the highest paying specialty and they're miserable, so don't go into something unless you're good at it, you're skillful. And then also know people who do what they're good at, what they love, what they get paid for, but the world doesn't need it. Maybe you're in some sort of you're doing some kind of project that doesn't matter to people and it's no use. So avoid doing that. Or you do something that you get paid for a lot of money, you're really good at, and what the world needs, but what you're really not passionate about. And I've seen doctors that are in that category as well. They comfortable but feeling emptiness. Each one of you happens to stumble into that one thing that you do in your life that you love, what the world needs, what you're skilled at, and the money follows easily. The money chase after you. The goodness chase after you. So I will finish with that. Thank you, Dr. Chan, for giving me the opportunity to speak to students.
Thank you very much, Dr. Liow, for the wonderful talk. Let's see from the audience whether they have questions. If you have any question, now it's time to ask from Dr. Liow.
Yeah, Dr. Liu, very good talk. Yeah. So So yeah, you try to it's very not a very interesting research about early detection. So also health disparity, you have done a lot, right? So really inspiring. So you talk about the early detection. You use EEG signaling, right? You try to integrate all kind of data, and when those diagnoses is for risk is how many years before the symptom you are doing. So I wonder at which time point you are using EEG signaling for diagnosis is my question. First question. Yeah.
Thank you, Dr. Dang. And no, EEG is not at a stage of specific nor sensitive enough for diagnosis. It is actually there are findings that indicates neurodegenerative disease. For example, when you have a ratio change from the high frequency versus the low frequency alpha and beta activities versus delta and theta activities, the frequency does change. It is clearly an indication of a chronic neurodegenerative. So it's neither specific, it can be although if we dive into it, there are certain specific EEG findings sorting out frontotemporal dementia, Lewy body dementia, but they're really not good enough. So I just want to caution that, this is, although it is very interesting, it can potentially offer a widely available, cost-effective and non-invasive way. It is still in the works, but certainly it is an active area of research that we're particularly interested in. Yeah.
Okay. So yeah, you also include image. There's one publication you show is including genomics information, image, biomarker, all kind of information. So based on your opinion, for those kind of diagnosis, do you think what kind of research we can still do? Yeah. So or do better than the existing study? Yeah. What's your suggestion? Yeah. For this, I'm talking about the diagnosis. Yeah. Early diagnosis for the Alzheimer's disease, AD disease.
Yeah, thank you. So we're already doing that. We actually have two groups of students working. One is working on a genetic data, looking at EEG correlation with genetic data. The other group of students working on EEG data and amyloid status. So we have patients who are amyloid positive and amyloid negative. Amyloid positive means that they have a certain amount of what we call amyloid tau positive. So we are already doing that. This data are being collected. So we are doing it. Yeah.
That's great. Do you have biospecimen available, like a blood or some biospecimen available? Biospecimen, I'm sorry. Biospecimen available? Blood sample. Do you have blood sample available? Blood sample.
Do we have blood samples? No, these are really pilot projects. As you know, not everybody gets a spinal tap. So we probably have samples of close to about 100 patients with CSF biomarker, and genetic data is a little bit more. So obviously, we would love to work with the biostats quantitative health department for to get. But this is a pilot project. Yeah.
Okay, if you want to do some genomics, omics, we can help you. Okay, we have done a lot of genomics.
Really?
Yeah, we can help you. Yeah.
Thank you. Yeah, we should talk. Thank you, Dr. Dang.
Thank you. Good job.
I think Lindsay has a question.
Okay.
Yes, thank you for your presentation. That was, I really enjoyed that, and that was really helpful career development wise as well. My question is more related to the career side. You mentioned a lot about resiliency and persistence. Do you have any additional advice for when you do feel like you're hitting those walls and you don't know how to get more experience or go forward?
Yeah, I do have a lot of experience because like I shared, I endured many no's and many rejections before I came across that one. Before I came upon Dr. John Rose, who took a chance on me. I still talk to him today. Dr. John Rose. I think he's probably in his 80s. I still talk to him. You know, the really you just can't you know, you just can't let, you know, there is this group of people, and since we're talking about Alzheimer's, if I could just share with you, called super agers. I don't know if you're familiar with the term. Super agers are people who are particularly have thicker cortex when you measure the cortex on the MRI, and they have particularly high number of von Economo cells in the anterior cingulate gyrus. You know, I know it's a lot of words. Von Economo cells are actually cells, you know, and these people are actually fairly resilient to developing Alzheimer's disease. You know, they have done research on this super agers, this group of people. Super agers are defined as people in their 80s or older who has the mind and cognitive ability of people in their 40s and 30s. We think that after 30 years old, your cognitive abilities decline. Okay, so this super agers, one of the characteristics of this super agers is two characteristics. One is they're always up for challenges. They're always challenging themselves, taking up new tasks, learning new roads, learning new things. So don't be afraid. The second characteristic that I think is applicable to your question is they are resilient. They often view, they've studied patients, they've studied people who survived Holocaust. They've studied patients, traumatized PTSD patients who has been prisoners of wars. These people have turned out to be super agers because they have learned to view trauma, challenges as opportunity. So if anything, I would encourage you that whenever you come across a challenge in your life, an obstacle, one as an opportunity, think of it as something that is solvable, because at some point, it is definitely solvable. You know, not only is it solvable, but it's an opportunity for you to do good and bring other people along. So, so be a super ager. Von Econo cells, anterior cingulate gyrus. Sorry for this long answer, but I'm really excited. But don't get me talking about these things.
Thank you. I appreciate it.
Dr. Liao, thanks again for presenting for us and for all the collaboration and support over the years to the department. So, yeah, I have to concur with Dr. Liao. I had a similar experience when I was younger. I was asked to meet at 7 a.m. on Saturday, so probably a little bit better than the Friday night, but still quite an experience. Dr. Liao, I would like to ask a question. You know, your center have done so much studies and clinical trials, but my understanding is that a lot of those studies that we serve as a site that's sponsored by pharmaceutical or NIH. My question to you is, based on your experience knowing Hawaii clinical research capacity, what do you see as the potential or possibility for Hawaii to run their own clinical trials rather than as a site? Part of the reason is that in Hawaii, there's a lot of natural product and alternative approaches that may not capture the attention from the big pharma, but could have a lot of potential. It would be nice that Hawaii can do their own studies. What do you think is lacking, and what do you think is the potential? Yeah. Thank you.
Yeah, thank you, Dr. Chen. I hope I didn't miss too much of your question. Was fading in and out, but it could be my connection on my side. So let me repeat your question. Running clinical trials in alternative complementary medicine in Hawaii. I think it's wonderful. You know, if there's a need for it, you know, because a lot of our patients are rather averse to traditional medicine or even clinical trials. So I think there's a need for it. The number two is it doable? I think with the right people collaborating, I believe Jepson has a complementary alternative medicine department. I don't remember the name of the person, but there's also several physicians in town, like Dr. Elizabeth Chan, who's wonderful, who's doing acupuncture and things like that, who would be willing, music therapy, and so I think it would be wonderful, especially in the field of Alzheimer's. I think it's great to if we could have a project looking at music therapy, or I think the potential is there. I think we just need the right, the patients are there. The logistics, it would be the challenge. I think we have the expertise as well. But obviously we would welcome collaboration from the quantitative health department, such as yourself, Dr. Chen. Hopefully that answers your questions. Did I miss any part of your questions?
No, that's a majority of the question. I guess one aspect is what do you see as lacking from the logistic running a clinical trial, handling rather than serving as a site of a multi-center study, but really design and conduct the study by ourselves.
Okay. Yeah, okay. So let's say you have somebody, PhD, like Dr. Nichols, who's developing a compound and he wants to launch this thing off or something from basic science. And I think the big thing is funding. It's just getting the trial design, the trial conception, and then selecting clinical trial sites and involving a CRO, clinical research organization. Those are very expensive ventures. So a lot of times, you may get started first, but eventually you will need to involve the venture capitalists on board. I think funding is the main barrier for something like this to originate from Hawaii. Not to say it cannot be done. Most of these ventures, I work with several CEOs closely on from beginning conception to they would get things started, and then after that they sell their company to a bigger biomedical or pharmaceutical company. And I've seen that process, I've gone through that process with them, both as an advisor, as a friend, and I've seen the challenges. Not that it cannot be done. I think the main barrier is really funding. And we don't have a good infrastructure of clinical research organization. We're not in North Carolina where there is a research triangle next door. It was even tough for me when I get started with clinical research. We just didn't have the people. I was told that the large institution hospital, try to do this, you can't do this. So I actually had to train our coordinator from scratch and from the mainland to train them. So it takes a little bit of investment, but we do have some momentum. And if there's opportunities that I can help support Dr. John Chan, something that you're looking at, it would be my honor and pleasure to support that. But I think funding and infrastructure is a barrier still, I think.
Thank you very much.
I think we're out of time, but I think that's one. Somebody has a question. Chelsea, why don't you ask your question directly from Dr. Liow?
Hi, thank you. I have two questions actually. The first one is, would you say that people who have a master's degree have an advantage over MDs who don't in terms of doing research? And my second is, this is completely unrelated, but do you have any advice for someone who's studying for the MCAT?
I can answer the first one very quickly. I think people with a master's degree, especially MPH, has some advantage. For example, one of our medical students, Anita Chong, who is just our top research student with us, has an MPH from Hopkins, I believe, and she is just publishing and doing this data like crazy. So I think definitely it gives you an advantage if you have that, and when you're studying your medical school, it definitely puts you out in front. So if you're already doing a master's degree, keep at it. Finish it before you're applying for an MD. Second question is advice for taking MCAT. I don't know how to do that because the truth is I never took the MCAT, believe it or not. You know, I somehow I slipped through the crack. I came straight from Singapore and I was getting admitted into St. George's University in Grenada. So I can't really give you any advice on taking MCAT, but if you want to email me, I certainly have a lot of medical students working under me who has done, so brilliant students who've done so well in the MCAT. I hope you give you advice, but so sorry, I'm the wrong person to ask.
Thank you.
Yeah, looks like we don't have any other question. Thank you so much, Dr. Liow, for your wonderful talk. Now let's give a round of applause to Dr. Liow, and then we will end the session from here. Thank you. Bye.
You're welcome. Bye-bye.
Thank you.
You're welcome.
Thank you.